Hi, everyone. I'm Matteo. That's my Twitter handle. Start tweeting at me. If you don't like it, it's fine. OK? I work with nearForm, as said. Anyway, today, I will talk about this project I've been working on for some time called UpRing. What is UpRing? UpRing is a framework for doing application-level sharding for Node.js. What does this mean? Whatever. Doesn't matter, really. So instead of talking about the framework, I will start giving you a demo. There's some code there, so you can try it on your own. Now, because I am a very, very lazy guy, and a lot of people get fancy with Docker and everything, instead I just my own automation using shell and Tmax, okay? Because I need to spawn up a lot of peers. So I have 7 tabs open for this demo. Hope everything was fine. So we'll see. Hope the demo gods are with me. Everybody, please. So let's open up a new tab. So let me show you what UpRing, this is a visualization of UpRing that I did some time ago. So UpRing is a distributed as a tool for building distributed systems to run in the cloud, very likely. What you can see on the right is a number of 3 peers. Can you all read that? Maybe not. Let's zoom in a little bit. Yeah, it took me like 30 minutes, 3 hours to just get that. So I have 3 peers running on my Tmax. You can run thousands if you want. But otherwise, the visualization doesn't really work. So anyway, so this demo that I'm going to show, it's about building a little key value store. So how can you build a key value store? How a key value store work? So first of all, we have a nice shell terminal. I hope everybody can read this. And I love curl, because, again, old school automation. So let's store some value. Well, first of all, let's see. So I have Nginx doing load balancing against all my 3 peers. So if I reach 8082, wait, it's nothing. OK, 404 here. Very tiny, but yep. OK, now you can see it. 404, Italian, because I'm Italian. So hey. So first of all, let's store some value in my key value store. So hello, rebels. And we send it to my to that endpoint. So hey, we have stored some data. Now we can see in our visualization that that data has hit this particular peer. That peer is responsible for that data. Okay, let's call the leader of that data. Okay, we also have a nice search box here that allows us to look up where that data lives. OK, let's try something else, also /hello. You see it's moving. Let's try web rebels. Still working, OK? So anyway, so this is the guy. Yeah, we have stored some data. Let's see if we refresh. Yeah, hello, rebels. Little at the top, maybe let me more zoom, OK? OK, so we have stored some data here. We can store data also on other things, so on other endpoints. So hey, we store some data /Node.js, and we do Node.js here. And we store hello rebels, and we see we have Node 8 now. We have Node 8. And we refresh, and we have Node 8 here. OK? Well, this is just a key value store, like Redis, whatever. Not so useful. Maybe yes, maybe no. Let's get some fancy. So I don't know how many of you know about server-sent events. I use server-sent events because they're really easy to demo and code. So, but you can use whatever you want, really. So let's just use server-sent events here. And Node.js, whoop. And then live true, which enabled my server-sent event code. And now you see we have Node 8. We have Node 8. So now let's send some new message in Node.js. Because it's broken, OK? So, and as you can see, we got a nice live update on my other thing. And if we go back to, oh, I didn't want to do this, really. And if we go back to my visualization here, whoa, now this doesn't work anymore. Yep, completely gone. So let's store it again. And yeah, Node.js. OK, Node.js is here. What we can see is that this is allocated to this particular peer that is on port, that is exposing port 3 on 303. And in fact, this is what the load balancer will call. And hey, we can open it up. And yeah, here we go. This is slash, OK? And if we go to Node.js, we have the same phrase. So what can happen? Well, this peer is responsible for this data. So I can go, you see I have all my peers. And I have, this is my peer, just received that request. So you know what I'm going to do? I'm killing the peer. It's dead. So now if we go here, my control system has noticed that there's only 2 peers available now. That peer is dead. And if you look for /Node.js, where it is? You know, demagogues, I knew this was going to happen. My D3 is really bad, so whatever. It's not displaying anything anymore. Always. Big question. In here, now, if we refresh this, it's dead, OK? But if we go here to the load balancer, we have still the same exact data, because that thing has moved to one peer to the next, OK? So yeah, Node.js, now it's here. So now it's being handled by peer 3044. That data has migrated and has created the data was migrated, and now that guy, that peer, is the leader of /Node.js. We can even spin up a new, again, my server, OK? By the way, Pino is my logger, so you should use Pino. You see a lot of things happening here. And this guy, hey, you've seen the peer has all gone up now. And if we refresh, we will still see, hopefully, the same data. What happened to my curl? Now, that curl is dead because maybe it was handled by that peer. So big question. Anyway, we still have all the capability. So this is a little bit of an intro on what UpRing does. UpRing enables you to write those type of systems that allow you to sustain failure easily and keep holding a state wherever you want. Now, the reason I built this is to support live updates to our users. Okay? So what happens if you want to deliver live updates? So how many of you have tried to do any WebSockets in your life? Yeah, probably everybody. So you probably know that whenever you have a WebSocket connection, you are holding some state on the server. That it's, and then you have maybe you want to send data to that user that originates from a different peer, OK? And in fact, this is what happens between the 2 servers. OK? They start fighting. Do I own the data? Do you own the state? Whatever. What happens if that peers fail? How do I migrate my state to the new peer? So, well, the big question is, how can we know which node under what connection? How can we manage state? There is this nice principle called divide et impera. I did a little bit of classical studies at some point, so not the best period of my life. So this is what application level sharding is, OK? So instead of saying, well, all the peers, all the nodes are equal and stateless, but we are handling stateful things, which is a connection. So what we do instead is we say, well, all the data related to user 1235 goes to server A. Poor server C receives no data, OK? If you're doing round robin or typical things, in fact, any node, the third request will go to C. So, well, the key point there is how can we assign data to our servers, OK? We have seen that we have this nice circled situation that I used to demonstrate everything. So the key point is, well, I can do it statically, OK? I can just say I have 3 servers. This bunch of users goes to this server, this other bunch of users goes to this server, and the third part of users goes to the third one. Hey, easy, done. Not so much. But we'll see that in a moment. So in UpRing, what happens is when you do a request and it goes to the load balancer, you can actually have a round robin across the cluster, whatever peer. But whichever peers you target, you have a one-hop connection to the actual peer that is going to maintain that data. How can we do this? We use a hash. I hope everybody knows what a hash is. OK, we did a nice talk about security, whatever. We have a nice, all of you know what a hash is. Well, you can actually, usually you are familiar with things like SHA-512, probably, if that's what you should use. Or MD5, not use that, please. But instead, you can do a non-cryptographical hash that maps anything, any string binary data, to a 32-bit integer. 32-bit integers are amazing because you can cycle them. Okay, so whenever you bump into, so if you keep adding 1, at some point they're reset to 0. Hey, so you have a nice circle. Okay, so what happens is that we organize, or we say our peers, that between a number and another number, 2 in 32, the guy, this peer, is responsible for all the data that are hashed in that specific segment. And then I have other peers that are next to it. So we have A, B, and C. However, in order to handle failures and be able to be resilient, we also need to copy our data. Okay? So the key point there is that we copy twice. Why we copy twice? Because we want to be able to sustain 2 failures. Okay? Very easy. So all of this is based on this paper. Okay? If you are into, I've had a Ph.D., so I don't know, I love reading those type of things. I did this for a living for some time. So this is a paper from AWS. It's really a very nice paper and a milestone, I would say, in computer science and database technologies. You should read that, or no, whatever. What UpRing implements is called the strategy 1. This is exactly the same example I did before, so I didn't invent anything there. The big question is what happens when a peer dies, because that's the point, right? We want to be resilient. And I demo that, so there should be a solution. So the point there is you have hashed your value so that you have a peer there, okay? And you've done your copies, so also B and C have a value. So when A dies, what happens is B stays covered, okay? Because it's the next guy. So that point in my arc is not there anymore. So the other guy inherits all the data and is responsible also for all the stuff that A was responsible to. Hey, still, how do we know our peer died? So we need to detect failures. Now, detecting failures in distributed system is kind of a very hard problem. It might look simple now because there's been years and years and years of research in the scientific community. But, you know, it's still hard. Because what you know, after a piece dies, you don't want to be in this kind of situation where you don't know where your peer is. Which one should I pick? Okay, which one is the right one? So what we need is something so we need a system, an algorithm, okay, that is very scalable, that can detect failures very quickly over thousands of nodes. Okay, because, well, hey, it's a cloud, so thousands of nodes. We want it to be weakly consistent, because if it's strongly consistent, if in case of a failure, everything goes down. So, hey, not exactly what I was building this for. So weakly consistent. I want it to be infection style. Now, I don't know if you know about what it means, infection style type of things, but it means that if I send some data to you, you can forward that data to one of other peer, so that I don't have to send the data to that peer as well. So the data in my network, the knowledge of if somebody is on the network, it gets spread really quickly. And this is a membership protocol. That's the actual term for this type of algorithms. So it means that, well, I'm detecting which other peers are in my cluster. This is called Swim. And in fact, it's another nice paper from Cornell. So again, another nice paper that you can try and use. This is a nice module, really nice one. The algorithm for this, that module was written by Uber people. So they are using this in production. It's really nice. You should, again, read this paper if you are into distributed system. It's really fascinating. So what UpRing does? UpRing organizes my data in a consistent hashing. That's the actual term for what DynamoDB does. And use Swim to detect failures. So no, it's not magic, OK? It's definitely not magic. It actually works. So how it does the consistent hashing, use the hash. Instead of a static table, use a hash to connect, to allocate the data to my peers. And yeah, you have probably heard of, have any of you heard about Raft and Paxos? This is the moment where I lose my audience, OK? Typical moment when you're doing a talk that you're losing your audience. So Raft and Paxos are algorithms using in database systems to elect a leader. So it's what your typical database uses to guarantee that the data is consistent. So in UpRing, a leader is basically decided statically based on which other peer are in the system. While in Raft and Paxos, there is a single elected leader. They connect together. How many of you has used etcd or console? Same people, probably. That's what they use internally, OK? So, in UpRing, the stability of the cluster depends on the gossip convergence. So the peers talk to each other and detect failures. And because of this, they actually, and this is guaranteed that my cluster stays up. In Raft and Paxos, instead, you need at least 3 nodes to operate better 5. Now, if you had used Kubernetes, you have one of those clusters running around in your system. So that's what it is. So well, let's go back to my title, because I haven't built a pub subsystem yet. So I need to demo that. So how can we build a pub subsystem with UpRing? So first of all, let's say that we have a publish, OK? And when in a pub subsystem, you have a concept of a topic, where different users publish some things, or a chat room, or whatever. And well, because of this, because of the same right idea that we have done before, we hash our topic, and we go and publish it to the relevant node. And then it copies over. It does the same publish to the other nodes, because we need to replicate. So well, what happens with the subscribe? Now, with subscribe, I want to get that data live when it gets published. Now, if the cluster is stable, it's very easy, because the load balancers can route it to any other node in my cluster. And because of the hashing system, I can hash the value, and I get the exact same node. However, if there is a movement in my cluster so that there is a peer is dead or a new peer came up, the subscribe connection can go to a different peer. What happens in that case? Okay? In that case, because we are publishing forward to the next one, in fact, we can actually still receive our data. So how do we do wildcards? Because that's the point. Like when you do pub, I want to know everything that happens wherever, OK? So what it does, it creates a tree internally. And it actually subscribes only to the peers that are responsible for that specific topics. So now is the time of the demo. Let's see if the demo gods are with me again, maybe. So I need to old school automation, OK? So because I did old school automation before, I'm still doing old school automation right now, OK? So hey, this is popped up. So let's kill all the previous one, and let's still open 842, and I still have my 3 peers as before, OK? So again, I can say /hello, well, or maybe hello, I don't remember. So hey, there, OK. So now, instead of having the curl interface, I spent some time with my very extremely good design skills to develop this interface, OK? If somebody wants to help, hey, please, I'm very bad at this. So what we can do now is subscribe to some stuff. And now when we subscribe, we can go back to our UpRing, and hey, here we go. Okay? So this peer is responsible, 3042. So we are here. Now we can publish stuff. So, and we get our data, okay, straight away. If we open up another terminal, and this can go to any others, because we have Nginx doing perfect load balancing, and round robin is going to another peer, and we can still subscribe. And if we publish here, here we go. This guy receives it, but also this guy, the other front end receives it. Now, obviously, all of this makes very little sense if we can sustain a crash, okay? And if you imagine how I debugged all the crashes of those systems and all the bugs, because I was preparing my talk, okay? So we can see that 3042 is the peer that is responsible for it. Now we go to 3042, and you see there is received messages and writing data. Hey, you know what we do? We kill our peer. So now there is some magical things that are happening right now, and that there is all the connection that was done to that peer needs to be reestablished to the new peer that is responsible for this. So some things migrated, and let's see if my thing still works. Maybe. OK? And it didn't. Perfect moment. Like, you know, this is even crashed. Let's try it again, OK? Because the demo god should be with me. So this is completely, like, I can't even refresh this. This is completely crashed. So let's dump Nginx. So let's connect to 3043. This is 3043, and this is 3044. OK? Now, which one is responsible for my thing? This guy here. So let's make a new subscription. So hello. Here we go. And here comes to hello. Here we go. So we have two subscriptions here, and this peer is 3043. OK? And then let's see. Let's open up another one to 3042. And here we go. OK? So now we are killing 304. Which one was? Keep forgetting. 3043. OK. So let's kill 3043. OK? Now this is dead. OK. So somebody, as you can see, has sent a new message and subscribed again to 3044. So 3044 is responsible for this. So if I publish this, I should receive the message. It's completely not working. What? Topic already added. So this is a typical situation I don't want to go. What? Wait a second. I'm doing it again. Sorry. Should work. It was working 5 minutes before. So let's do it again. And here we go. This is dead. There's something going on in my Chrome. Localhost 3043. So here we go. Hello. Hello. And the peer that's, yeah, let's press this. So, yep, this guy. OK, 3043. So if we publish this, hello, you go. This is not receiving anything, but this guy is receiving the data. So let's crash 3043. So in 3043, this is the guy. So this is the one was responsible, 3044, and we have our connection. So maybe now it's working. So anyway, so the 042 was dead. That's with 042. And we can bring the node up. And OK, so yeah. And we publish. And as you can see, the 3044 guy is still receiving the data, even if the topology has changed back and the node is added again. We can also do wildcards. So we can subscribe to 8082. We can subscribe to hello plus. And then from another guy, we can say hello rebels and say woo woo. And we publish our data here. You see this hasn't received it, but this subscription here has received the data accordingly. There is something going on wrong on my JavaScript, so whatever. So anyway, what is the API of this? I'm going quicker because I've lost a little bit of time. So it's really easy to use. You can instantiate it, UpRing. You can specify log level. I'm really into logging. You can specify the number of replica points in your hashing, how many times your data gets hashed, and a timeout for join. When sending messages to UpRing, what you do, you specify, you pass an object. A message in UpRing is just a simple object. What you do, the most important property is key. That's what's going to get hashed. And then you add some patterns. So you need to add some, to receive those messages and to handle with those messages, you can actually add multiple ones, whatever. But you need to specify the command you want to handle and the namespace for that thing. So while here we say this is the code from our key value store, so we use just a map, and that will return OK, true. We can also do live updates. Okay, so how do we handle live updates in this system? What we use is we use Node.js streams. I hope all of you love Node.js streams. I'm maintaining that, so if it's broken, please. So what we do, we can just return a streams key and passing our stream through in, and it will just get automatically recreated on the other side. So in fact, when you are receiving a response, you will get a stream on which you can attach data handlers or pipe to or anything like normal streams. You can also track things. So you can, with track, what you can do with track is know when there is a topology event for that specific key. So if another peer comes up that the data needs to be replicated to, you got a replica event. Or if you want to move that data to another peer because you're not responsible for that data anymore, you get a move event. And then you can do some logic on that. You can also have a replica function that will be called when you become the master for that key, the leader for that key. Okay, so the node can know about this. It's not too complicated if all of works. So again, I'm pitching again Pino. Pino is my logger. You've seen the nice tree. So you probably get every of you to get a sticker. It's really simple logger. So anyway, just summing up, what is UpRing? UpRing is a framework to build a key value store, or a cache, or a pub subsystem, as I showed, or a real-time application, or a discovery system, or a metadata store for microservices if you are into microservices. Whatever, how micro they are depends. How many lines of code? 10 lines of code is a microservice. And, or anything that requires managing state. So some links. This presentation, this is UpRing. UpRing KV is the module that I've done for the key value store. The UpRing controlling the nice D3 animation, I know. I had a lot of fun doing that. UpRing PubSub, it's the PubSub system I showed you. Now we have this presentation. It's available there. So hey, check that out if you want or not, whatever. And I work with this company, nearForm, so sorry for the pitch. And we are hiring, so hey, if you want to join us, we are a 70% remote, 100-people company now. We do software for third parties. We are professional services, Node.js consultancy, training, whatever you want on JavaScript. So I want to thank you all and thank my colleague Luca Maraschi that helps debug this presentation multiple times. So thank you all. Now it's the couch time.
Couch time. Everyone's favorite time. The demo gods were with you in the end.
A little bit,
They're finicky, but
yeah.
you made them bend to your will. Someone from the audience said, "What's UpRing? Oh, not much ring. What's up with you?"
Sorry? I didn't really get that.
what's up, Ring? It's like, what's up, Ring? Not much.
Oh.
What's up with you?
That's more or less what happened with 2 different nodes.
I didn't make the joke, so I can't take credit for it. Another question from the audience was, does UpRing handle something like transactions, like data guarantees about when your data has been added to nodes?
So UpRing, it's eventually consistent. So whenever there is, whenever the topology and your cluster is stable, meaning that there is not somebody that dies or not, everybody's available, then you have a strong guarantee that the data is being handled sequentially. Because Node.js is single process, okay, single-threaded. Mm-hmm. So whenever that peer receives the data, you actually know that you are the only one writing that data. When problems can happen, it's where there is a topology change and the peer dies. So in those cases, of course, you might end up, there's a light chance you might end up in a split brain situation where there might be some collision happening. So the actual answer, it's not.
Could you layer a kind of transaction system on top of it? So it doesn't come with it out of the box, but could you add that on top if you needed to? Does that make sense?
I think you can code everything, but I strongly believe you can code everything.
Okay.
But I would say if you need a transaction system, use Postgres. It's probably better than whatever I can write. So yeah, that's more or less my
Okay.
detail.
So it's for a different kind of
Yes.
constraints, basically.
Yes.
That makes sense. So say I'm new to distributed systems, and that was really exciting to me, but there were parts of it I didn't quite understand. Where should someone go if they're interested in distributed systems and they want to get kind of a broad overview of what's going on with that? They could get a Ph.D.
Yeah, that works.
Maybe
Probably
they don't have time. Or
probably not so much for your life, so don't go there. First of all, there is a very nice workshop tomorrow that you can go to. Peer-to-peer systems are a type of distributed system. So the actual way I think everybody started learning about things, it's by doing experiments. So that's, I think, it will be the best way. Code stuff. Okay, so start coding. And whenever you start coding, then you notice, oh, how I do this? How do we do an election? And then you open up your friend Google and start Googling up things. There is also scholar.google.com, which is really good for searching papers. Most of the old papers and most of the stuff you want to read are open access. So you can find those papers available for free. You can download them and read them. If you're not into reading papers, there's NPM. There's a good community around like protocols and so on. Node.js is really good at doing a parsing protocol implementing distributed system. So you can go there as well.
Awesome. Thank you so much. That was fascinating. I'm glad your demos worked out in the end.
Yeah,
Thank you for coming.
I hope so. Thank you, guys.
Great job.